So today we have two grad students from the Sky Computing Lab at UC Berkeley, Jain and Sarah Wooders, and they're here to talk about an interesting project called Skyplane. So welcome both to the Data Exchange podcast.
Thanks for having us.
Yes, thank you.
All right, so Skyplane. So I'm going to ask you first what Skyplane is, but I think since everything is kind of tied to this concept of sky computing, maybe we'll start there. So very briefly, what is sky computing?
Yeah, I am happy to cover that. So sky computing is a project that started about 2 years ago. Jan Stoika and Professor Scott Shanker started kind of an initial white paper on that. And it's grown to become a large effort, basically focusing on how to enable applications to operate seamlessly across multiple cloud boundaries. And so you can imagine moving the world to this world where a single application may use AWS and GCP concurrently in order to get access to best-of-breed services, better databases or better kind of infrastructure technology, or perhaps specialized hardware, right? But how to enable kind of this cross-cloud vision.
All right, so then we get to what is Skyplane. So I always start by quoting what people have on their websites. So in your case, it's blazing fast, not just fast, blazing fast, bulk data transfers between any cloud. And this quote is quoted between two fire emojis. So, so what exactly is Skyplane?
Yeah, I'm happy to talk about that. So Skyplane as a project, it aims to essentially solve the problem of data gravity in enterprises today, right? And so the key problem here is that data is very slow to move between different regions within a single cloud or between cloud providers, and it's very expensive. So you have to pay for high cost egress fees. And so our tool makes data migration very easy. So using a simple CLI in our open source project, you can point it to any source in any cloud and any destination, and we will move that data at up to 100x higher performance and 10x lower egress fees than the best kind of competing alternatives today. And so that's where the blazing fast comes from. I hope we live up to it.
And by data, you mean any kind of data? It could be structured data, it could be video, could be Parquet files.
Mm-hmm. Yeah, it's a really good question. So today we support object stores. So we have support for AWS S3, Google Cloud Storage, Azure Blob Storage. We have upcoming support for on-prem storage, such as MinIO and local file systems. And we're working to extend support for Cloudflare and IBM Cloud soon. But that's for object storage. We're adding now support, and this is very, very early research work for structured data types. And so this is more things like snowflake tables or Delta lakes, Hudi tables or iceberg tables. But that's an early project. It's not yet landed in the open source.
And also transfer, is it mainly, so was the origin story of the project premised on people transferring between cloud providers or between regions, or what was the motivation?
Yeah, so sky computing started about 2 years ago, and I thought it was a very compelling idea, right? Like, when will we have computation as a utility? It's a very clean and I think elegant idea, but when you start to look at the reality of running applications across cloud providers, data gravity is actually a really clear problem. You hit it within 10 minutes. So I actually went and started implementing a distributed ML training example across AWS and on-prem. I tested some basic data analytics workload and like a web serving workload. Each of those situations as just like early prototype workloads of the sky. And that was 2 years ago. I hit data gravity very quickly. Like, the application was, significantly slower and cost more to run because of this data transfer issue. So in some sense, directly motivated by that problem, it really kind of focused the Skyplane project around this to say, if this is really the most important question in kind of enabling sky computing architectures, that is data gravity, how do we solve that? And so that's focused the entire kind of project around this kind of thesis.
And just to clarify, data gravity impacts someone using a single cloud provider, right? Because they may want to move to a region where there's a specialized hardware.
Yes, that's a really good point. So many of our users may have started, say, in US East 1, and then now they need to have a region in the EU and in APAC for compliance reasons, or to reduce latency to users. And so there they will still hit that problem. I think the reason we started with, again, intercloud is because the problem is so much worse there. When you look at network transport between different cloud providers, it's extremely slow and poorly provisioned today. But even within a single cloud, we provide up to 5x throughput improvements compared to, say, a tool like AWS Data Sync. And that's just from AWS region to AWS region.
Another thing I'll note about single cloud multi-region transfers is that there's actually a huge amount of variation in the pricing per gigabyte for egress. So even if you're within a single cloud, if you're trying to broadcast data from one source to many destinations, but you happen to be in a region where the egress is extremely expensive in that region, then Skyplane can actually run optimizations to make sure that you don't repeatedly pay that expensive cross-region egress and instead move to a cheaper region before broadcasting the data.
So at this point, so who's using Skyplane? Is it mostly still in the Berkeley family?
So we started here at Berkeley. There's several projects trying to build cross-cloud applications for data warehouses or machine learning, other applications. So we have internal users, like academic users, who have been trying to use it. But very quickly, we've gotten a large amount of industry adoption for this technology, and it's just simply motivated by, I think, very clear use cases people have in terms of managing multiple regions within a single cloud. And the performance for our tool compared to actual vendor solutions, so like AWS Data Sync or GCP data transfer or other production data transfer solutions, we're so much faster than kind of the state of the art here that it provides just a very clear benefit for organizations. So there are several large organizations and enterprises who've begun to use it. I think, Sarah, you can talk about some of the use cases people have been using it for.
Yeah, so I think one of the use cases that we're really excited about is just sharing data across clouds and regions in general. So this gets into Skyplane storage, and then also things like publishing models or Docker containers. So those are both scenarios where you have like some large piece of data, whether it's model weights or your container, and you basically have to transfer that data to a bunch of different destination regions. So right now, that's often a huge bottleneck just because you have to transfer that data across so many regions. But we want to basically apply the improvements that we have through some of the Skyplane research to make that a lot faster and cheaper.
So have you tried to maybe survey is too formal, but have you tried to conduct like an informal question and answer with your users in the following sense? So are they mostly doing machine learning? Are they mostly data scientists? Are they in a specific industry? Or are they they're probably not in industries where data transfer is allowed, like, I don't know, healthcare or whatever. So can you give me an idea of who's using it outside of Berkeley?
Yeah, so there are several organizations using it for large-scale data analytics. So, for example, moving kind of Parquet stored data from one region to another. And so here, the setup is you might have, again, like several geo-distributed kind of databases for each kind of US, EU, APAC, and you need to centralize that data for analytics. There are some machine learning use cases, but we actually find a lot of the use cases are less intricate than the cross-cloud kind of vision that we originally kind of set out to solve. They're, cross-region data transfer, and many of the users have SLOs for the data. So we talk to a major chip semiconductor manufacturer who needs to bulk egress data from Taiwan to the Netherlands on a daily basis. And this transfer needs to complete in 20 minutes or less, right? And so this is actually a production application. It's something we hadn't really foreseen. But this is, again, a really important that this transfer completes quickly, right? And so a tool like Skyplane can help them achieve that tight transfer SLO. And so that's actually another setting outside the data analytics and machine learning space that we started with that people are using it for.
Can you describe basically, in terms of usability, how accessible is the tool? I mean, is it meant for DevOps people that would, who have to do a lot of configuration?
Mm-hmm. Yeah, so we've packaged it up as a CLI. So you can kind of pip install it in 10 minutes or less, authenticate with your cloud credentials, and Skyplane then will manage a transfer for you. So it'll actually provision VMs in each of the regions for the duration of the transfer that you start. So its interface, at least to get started with in a very incremental way, is basically the same as you might type AWS S3 CP. Well, now you can type Skyplane CP and put any source and any destination in. So it's really meant to enable end users to kind of solve the jobs they already had to do for their workflows without having to think too much about the performance or cost of that kind of data interchange. So it actually doesn't require, specific setup by an infrastructure team in a company, although they could presumably set up a managed kind of endpoint for Skyplane. Second, I want to note that it requires no cooperation from the cloud providers. So we use only public APIs and public interfaces. And so this basically means you can basically deploy it without any special modification to your cloud accounts or anything. Like, doesn't require any OK from Amazon.
So the usage of the tool, I would imagine, is very episodic in the following sense, right? So I don't need to transfer data often. It's not like a streaming application or anything like that. So it's basically maybe once in a while I would use it. Is this an accurate assessment?
A lot of users start that way, but what's most exciting is that like once they kind of have this tool chain for high-speed data transfer, they start making these transfers more and more often. And so one use case where we've seen a lot of adoption is business continuity and disaster recovery. So when US East 1 went down, many companies added to their business continuity plans that they need data on 2 or more cloud providers within 15 minutes or less, right? And so that became a hard requirement for organizations. And so a tool like Skyplane is very useful in that setting because I can now egress that data from AWS to GCP and always have that fallback, right? Even if our AWS as a whole were to go down again, I would always have another copy of my data somewhere safe and secure. And so that's a recurring transfer, and that happens continuously.
So if Skyplane did not exist, I would use some tools from the dominant cloud platforms. And you started this conversation by quoting a number like 100x faster, right? Or something like that. So listeners out there might be thinking, this sounds too good to be true. So now start explaining some of the secret sauce and in a way that the listeners will find it credible.
Yes, I can go into that a bit. So basically, I would say the main thing that Skyplane does, which is the #1 source of its performance gain, is that it can basically massively parallelize your transfers. So if you're transferring a huge, like 1 terabyte file between 2 object stores, Skyplane will actually create an ephemeral cluster of a bunch of VMs in the source and destination and also overlay regions, which are basically intermediate regions, which I'll go into in a bit. And it basically is able to parallelize both across multiple machines and then also across multiple threads within that machine. So you have many parallel TCP connections. So this gives you basically like a huge performance gain because instead of just using one machine as you normally would, you're instead parallelizing across many of them. In addition to that, we also basically profile cloud networks to basically measure what is the throughput across different regions. And so we can actually use that information at runtime to basically determine, is this path congested between these 2 regions? And if it is, then to basically route around that along higher paths, higher throughput paths. We also have a number of other optimizations like compression and also finding like cheaper paths to route data along. And then also for broadcast, we actually create multiple distribution trees to offload the source egress bottleneck, which is often the issue with broadcast. So combining all of these, that's how you get those optimizations, basically like that very large number.
By the way, what are the knobs that the user can tune? So in other words, if I care more about speed than cost, or if I care more about cost than speed. So beyond those 2, so are there other knobs that I can turn?
Yeah, so so both with broadcast and like Skyplane point-to-point transfers, you can basically specify a target runtime. So then that it'll basically be under that target runtime constraint. How can you basically transfer data in the cheapest way? Other knobs you can tune are basically if you want to turn on encryption or compression. You can also modify the sort of the number of vCPUs you might want to use per region. So if you have different limits, you probably want to modify that limit to make sure that you don't go over that limit.
One important control actually that users have asked for that we support is control over your path. And so in some cases you can disable certain regions. If I know I do not want my data transiting through a specific country or continent or particular cloud, users want some visibility and be able to kind of control how their data is routed, which they normally wouldn't have. But with Skyplane, then they can actually go ahead and block a specific region there and actually carefully control the route. And that can help them meet certain data privacy regulations.
So, as Sarah described, so you have some data around congestion, pricing, and things like that. So, how up to date is that data? Because I imagine that changes constantly, right?
Yeah, so we've been profiling it about I guess every couple of months. But we've also found that these throughput profiles actually don't change that rapidly. So like if you kind of check them like day to day, they're actually pretty similar. But over like month or couple of month-long periods, it actually it does shift. So you have to reprofile the network. One thing that we've actually started doing is trying to use user data, anonymized, of course, to basically try to collect that throughput information for free. So you can opt into Skyplane metrics so that any users of Skyplane will basically do the throughput measurements for us. So based off how their transfer performed, we use those metrics to basically make other people's transfers faster.
You can think of this as like folding at home, right? So this is like a collective data set that we make public to everybody. And so as you kind of move data from one region to another region, you may log that you got, say, 4 gigabits per second per VM for that transfer. And that information is then shared with everybody. And now using that information, Skyplane can route around hotspots in the network, right? So for example, one of the ways we use this data is if you're transiting data, for, let's say from GCP to AWS, well, GCP and AWS do not interconnect with each other in every region, right? They actually only interconnect in a few places in the world. And so that information, that throughput grid that we collected from our users, and again, this is all opt-in, right? But that information actually reveals where GCP and AWS have kind of shared routers, right? Where they are connecting to each other. And so Skyplane will actually force the transfer to kind of go through where AWS and GCP are interconnected. And so that's just a benefit that you can get by kind of contributing and sharing data in this kind of folding at home style.
So besides the kind of the test data transfers that you folks have done, without naming names, what is the largest file transferred through Skyplane?
We've had a user try to move...
I mean, size.
Yes. So we had a user move in excess of 200 terabytes using the tool. And one of the things we do support is if you're moving a very, very large file, we will transparently chunk it up into little small pieces and utilize parallelism to move it. And so the existing cloud tool that AWS provided was moving that one file using one thread to move 200 terabytes, right? This was going to take ages, right? And so Skyplane was able to chunk this up into thousands of small pieces and concurrently transfer it resiliently.
So is the encryption feature something that people are actually using now, or is it mostly just something that you folks added?
So it's turned on by default, I believe.
Yes. Okay. So it's on by default. So the performance, there's no performance impact. And in fact, this is really important because you look at GCP data transfer or some of these other tools like AWS Data Sync, and the security and privacy narrative there isn't actually fully formed. So for example, you may be passing around, credentials, right, for access to your bucket. And so with Skyplane, we can end-to-end encrypt your data, and that key is generated from your laptop. And so in some sense, Skyplane, it runs in your own cloud, in your own VPCs and stuff, but even then still, it's always encrypted over the wide area network, right? So it's very secure. And we have several users who are beginning to use extra technologies like secure enclaves, for example, in order to customize how we do that encryption for use cases such as customer data onboarding into their clouds.
So the 100x faster, right? So do you find that people care about the speed or the cost?
It's both, right? So, I think people have a threshold where it's too slow for them, right? So that might be overnight, it might be an hour, or it might be a coffee break and they want it to finish in a minute or two, right? So there's usually this threshold that like taking a transfer that would have taken a whole day to complete and taking that down to something which can kind of complete within a coffee break, that's a huge transformational moment for a lot of people. But again, it's always at what cost, right? If it costs 100x more to get that performance improvement, it wouldn't really be useful. But what Skyplane can do is it can provide better performance and lower costs, and that is really what makes it, I think, uniquely attractive. More than just cost and the throughput, though, Skyplane has support for a lot of connectors out of the box. And so if you look at, say, a tool like AWS Data Sync or GCP Data Transfer, GCP Data Transfer supports only bringing data into GCP, but it doesn't let you take it out, right? And so
like
you have to use
California. Huh?
Yeah, exactly. Yeah. Skyplane supports anything, right? Any source, any destination, and we'll bridge it, right? And so that you only have to learn one tool chain and integrate with one API.
So right
that's
now,
actually
right now, if I go to the website, it seems like it's only the three cloud providers, Azure, GCP, and AWS. Are there plans to include other clouds?
Yeah, so we're currently working on an IBM integration. And then in addition to that, we're also planning to integrate with Cloudflare because they're actually S3 compatible. So those are the two that we have in mind. But it's also relatively easy to add your own cloud into Skyplane. So we're hoping that other people will contribute connectors.
So the Sky Computing Lab itself seems like so it's a great vision, but even Eon admits let's focus on ML for now, right? So I'm curious to find out why you think that in your case it's mostly, I guess, analytics people tend to be the ones who move data around more, or so why is interest in ML use cases less for Skyplane?
we still support ML use cases. One very interesting use case, actually, we've begun collaborating with folks behind Lion. And so that's the organization that made the or stable diffusion. And they have to move terabytes of data between regions frequently to train these large foundation models, right? And so actually in this new era of foundation models, I think it's actually a really big problem. But again, in terms of number of enterprises who are hitting this problem today, I think the majority are still doing data analytics and kind of more basic stuff, right? But I think the ML use case is going to become increasingly important. And we have been working with people to help support machine learning use cases on Skyplane.
So I think overall, though, sorry,
go ahead,
but I think we want Skyplane to be sort of a more like general purpose tool. Like the way we see Skyplane fitting into the Sky vision in general is basically like you can't have Sky unless you have really good networking and the ability to share data across clouds. And it doesn't really matter like what kind of application that is. It can be ML or really anything that involves a lot of data, which I think is most important applications. So we're really focused on enabling like those data intensive Sky applications.
So how many users are there now outside of Berkeley in terms of organizations? So you have a handful of companies using it, and probably other academic institutions, right? So at this point, then you have enough users, so people are starting to bug you about features, right? So what's on the roadmap for things that you need to do in the next 6 months?
So I think in terms of our roadmap, we've actually it's a really exciting time right now because we've sort of kind of completed like these core like networking components, right? Like doing like one-to-many transfers and one-to-one transfers. And right now what we're actually starting to think about is what are the applications that we can now build on top of these transfer components. So one of this is of course Sky Storage. Basically, can we create sort of like a virtual bucket that you basically interface with it as if though it's a single bucket, but under the hood, it basically replicates data across multiple clouds and regions and also determines how to place objects. Another one that we've been thinking about is also a container registry. How can you push containers or also models really quickly to a bunch of different regions? Because that's sort of the applications that we hear about the most in terms of what are the challenges for moving around data in the cloud.
So if a team starts using something like Skyplane, I imagine one of the first things they'll want is some kind of dashboard to figure out who's doing what and who moved data from here to there. So maybe that's not something you would build, but someone else would build some type of UX on top of it, right?
Yeah, I guess I don't think we've gotten that asked, but I mean the open source tool that we have right now, like we wanted to keep it very, very simple, like basically mimicking the S3 like our like copy commands, so that there wouldn't be like a huge surface area since we are like a small grad student team. So I think because that's quite focused, we're able to have something that's both useful without being a huge amount of software engineering work to maintain.
We have an API, by the way, so you can always puncture the CLI and talk directly to our API. And we already have several organizations who are trying to use this API to orchestrate data transfers more automatically. And so you can imagine, I think the way an enterprise might deploy is they might actually offer a managed service on top of our API to orchestrate data transfers across organization. Again, I think it's an emerging path.
Because one of the big things in enterprise data is governance, right? So understanding who's using what data, who touched what data, maybe lineage, uh, or maybe even a catalog. If I'm using Skyplane moving things around, so where's the data, and so on and so forth. So someone may wanna some of our listeners may want to kind of take this on and build kind of like a dashboard, enterprise dashboard on top of Skyplane.
Yeah, I think I could see that maybe becoming something that people want with the storage layer. I think with the CLI tool right now, which like we have, the API was like just released like yesterday. So the CLI tool that's been open in the past couple of months, I would guess that the most common use case is people want to do these sort of infrequent migrations. Like maybe you want to switch clouds for some reason, or maybe you need your data set available in another cloud. So I would guess that because that's the common use case, maybe people haven't wanted to do this like online and as much.
Right. So there's no log for how people used. So if I were to if I start using if I'm in a regulated company and we start using Skyplane, someone needs to keep track of who's moving things around.
Okay. So you can actually run a Skyplane client in a central location. Okay. And so that we have local logging and auditability about what's actually being moved and where. Obviously though, starting with smaller users and academics, the CLI is important, right? Because what Skyplane does support that's very unique is scale to zero. You don't have to pre-provision your network infrastructure and keep it alive even when you're not doing transfers. We ephemerally bring up all those resources for the duration of transfer. So you only pay for that little segment of resources that you use, right? And so in some sense, like that is a model we feel is actually much more interesting long-term. Where users kind of can ephemerally provision this networking resources where they can scale out to 100 gigabits per second, blast data over the network, and then scale back down to zero, right? But that doesn't preclude you from running it on a centralized tracker. In fact, to implement Skyplane storage, we do have a managed Skyplane endpoint internally that orchestrates the transfers in a central way across all clouds.
So you folks have mentioned Skyplane storage a few times. So can you describe the current status?
Yeah, so it's actually in the very early stages. We just wrapped up the work on broadcast. And so then storage was kind of the next natural extension to that, because you can basically use like high performance broadcast to replicate writes that you have in one location to many other locations. So it's a pretty recent project. We've like just started implementing things. But the idea was we basically want to enable users to interact with like a single virtual like object store interface, and then to have a centralized tracker which basically uses Skyplane to replicate data that's written in one location to other locations. And we also have a collaboration with another group in our lab with a grad student who has been looking at how to basically place objects in like different tiers or in different regions to optimize for a particular workload. So we're basically combining that optimization of where to place objects with Skyplane's optimizations for how to optimally replicate objects to basically create this very cheap and high performance like replicated storage system.
So at this point, I imagine the community of contributors is heavily focused on Berkeley. So are you starting to get contributions from outside Berkeley?
Yeah, we have. We actually had a couple contributions come in from someone at Opaque. Do you want to maybe discuss?
Yeah, that's a really interesting application. So Zizong, who is at Opaque Systems, another Berkeley spinout, has been looking at secure computation and how it interplays with data transfer. And so he's been working on improving the system support for systems such as secure enclaves. We had external contributions for new cloud integrations also. And so actually there's a contributor from IBM who is writing an integration for Skyplane into IBM Cloud. And there's a lot of small organizations, for example, Gridware, which is a small energy science kind of startup, actually contributed back major kind of changes to kind of improve the system for some of their data movement use cases. There's also some public organizations who we've begun to collaborate with. And so on NASA and the Earth data system, there are several open organizations we've begun to collaborate where they've been writing connectors for Skyplane to the Earth data kind of planetary kind of data system, right, that NASA offers. And so they have an 80 petabyte store of satellite data and other kind of data repositories that they manage. And so that's another external kind of contribution that has come in.
So for people who are thinking of using Skyplane, which by the way you can find at skyplane.org, I guess there's always a graduate student risk, right? So if the graduate students graduate, does this project end, right? So I guess the fact that it's open source, maybe you have more control, but it sounds like at least it's such a fundamental component of the sky computing vision that you folks at least will support it for the next few years, right?
It's a large team here of PhDs, so there's already 5 of us PhD students working on this project. As you said, it's one of the bedrocks for the Sky Computing Lab, and so it is a critical enabler for any application that is running on the Sky application stack, right? And we have actually a large team of undergrads also working on it. So yeah, and again, we now have outside contributors, and so I'm really, really enthusiastic about the health of the community and how fast it's been growing.
So let me
I think especially as project, sorry, but as we have like other projects building on top of Skyplane, it'll definitely continue to be maintained.
So let me close by putting Sarah on the spot. So what has been the reaction of the cloud platforms to Skyplane?
I guess like Google has been really, we've talked to some people at Google and they've been really excited about it. AWS, like less so. I mean, they really, I think like their sort of internal and external messaging is that if you have multi-cloud, you lower yourself to the least common denominator, which is expected from the leading cloud provider to say that. But yeah, I mean, obviously we disagree with that at Sky Computing. I think that you really enable cloud users by allowing them to pick and choose the best services from different clouds. And so I think that's really important. We have been trying to get the cloud providers to warm up to us a little bit because we've actually had really, really good results even for intra-region transfers. So especially with broadcast, we actually compared to AWS multi-bucket replication and found that we were a lot cheaper and faster. So that's kind of one avenue we're trying to show them that like Skyplane can be beneficial even for a single cloud. But I think because we support multi-cloud and really prioritize that there's sort of limits to how far that can get us.
By the way, one last question for us. So what does it take to add a cloud? So right now you have plans to adding IBM, but there's also Oracle. There's specialist clouds like Sigma. Is it or Lambda?
Mm-hmm.
Right. So what does it take to add a cloud to Skyplane?
Yeah, we've had conversations with quite a few clouds. So again, Oracle, OCI, we've talked to CoreWeave, Lambda Labs.
No, but is it a huge project? Is it a huge project to add a cloud?
It's very simple. It's probably under 800 lines of code today, and we're making it increasingly simple. One thing I'm really excited to talk about that's kind of happening in the Skyplane project, the SkyKit project, and so that's very early. But we're basically building common provisioning infrastructure, and so on that SkyKit infra, it'll be under 100 lines of code to add a new cloud provider. That's kind of our goal. And so that our goal is to make that kind of the common kind of provisioning stack for Sky computing applications. But again, very simple to add a new cloud provider.
So it's not really a technical problem. It's mostly just kind of developing that relationship and getting them to work with you.
Again, we can do it. It's very easy, but we prefer if the cloud providers can contribute it because there we have a support vehicle. And if there are issues and if we do need to escalate certain kind of integration issues, there's a path of communication to the cloud provider. So it's always better to kind of have that contribution come in from outside. We've had a lot of users ask for Cloudflare though, because it's zero egress fee. And I think that's something that interplays really interestingly. With Skyplane storage, for example, we can actually leverage Cloudflare as a data broker. So if you're sending data from one cloud to 4 other clouds, we can transit that through Cloudflare and you only pay the egress fee once. So that's a 4x cost savings just right out of the box with leveraging kind of these new specialist cloud provider like Cloudflare.
So this is my final question. I was a bit surprised when Sarah said that you guys only check the data every few months, because now the things are changing so fast, right? So you've got inflation and things like that. So really, so these throughput and this pricing doesn't change that often.
So it's pretty stable over time, and so we do like a full refresh of that data set, let's say every few months, so every 2 months. And so that's actually a pretty expensive process because we need VMs in every little corner of the cloud, in every little corner. again, our users are constantly refreshing that data. And so it's actually broadly kept up to date, especially for kind of, the largest regions in the US or EU, for example, across all the big three cloud providers. And so we have this data stream and this data loop that keeps it up to date at any point in time.
Yeah, the pricing is very static in general, I think.
Yeah. And with that, thank you. And again, to our listeners, you can find more details at skyplane.org.
Yeah, thanks for having us.
Thank you.